Okay, so we're looking at one of the applications of a sum of a GP, and it's called a limiting sum. So we've got the pattern, the formula we've worked out from a previous video, that the sum of the GP equals a bracket Rn minus 1 over R minus 1. Now, we'll show in a sec that if R is greater than 1, or if R is less than minus 1, the sum just keeps getting bigger and bigger. Like, so for instance, if I've got 2 plus 4 plus 8 plus 16, R equals 2, and we're just going to keep adding bigger and bigger numbers, so the answer would be infinity if I was adding those numbers up. But what happens is, if R is between, if minus 1 less than R less than equal to 1, if R is between those numbers, what happens is the sequence does not go to infinity, and we'll see that in a sec. Okay? So, if I add 4 plus 2 plus 1 plus dot dot dot, what value will it approach? So what I want you to do is just get on your calculator and just do another 6 terms and see what happens. So we've got the first 3 terms, work out what the next 3 terms is going to be, and see what the calculator tells you the answer is. Okay, so we're back. So we've got 4 plus 2 plus 1 plus a half plus a quarter plus an 8. So if you just add those terms up, you get 7 and 7/7/8. And then the next number would be 1 over 16, so the answer would be 7 15 over 16. So the next number would be 1 over 32, so the answer is that. So the answer's getting bigger and bigger, but it's not getting bigger by a lot. And so what's going to happen is, as you get bigger, as you add terms, the terms are getting smaller, and eventually you could guess that the number's going to approach the value of 8. Okay. So in general, what we've got is a new formula. So I'll just show what's happening again. So we've got Sn equals a r to the n minus 1 over r minus 1. Now what's happening is this term here, okay, so for instance we've got a half to the power of 10 or a half to the power of 20. This number's getting smaller and smaller and smaller, okay? And what's going to happen is when you get to infinity, a half to the power of infinity, it's going to equal 0. So what we've got is this term disappears, so we've got a times minus 1 is minus a over r minus 1, but rather than having a minus on the top, what we do is we actually just switch the order. So we've got positive a over 1 minus r. Okay, so this formula is called the limiting sum, and so we say the sum at infinity equals a over 1 minus r. Okay, for a pattern where the value of r is less than 1, or between minus 1 and positive 1. So for instance here, this r value is going to be a half, so there will be a limiting sum. So we're saying at the end of infinity, what's the answer? So we say a is r, the r value is a half, so we've got a over 1 minus r, 1 minus a half is a half, and then 60 divided by half is 12. So the answer would be 12 if you sum those up to infinity. Okay, so copy that down, come across. So let's have another example, this time with a negative one, just see if it does work. So a is 4, r is minus a half. Now just divide those two terms together, minus 2 over 4, okay? So the limiting sum, the sum to infinity, is a over 1 minus r, and r is a negative. So we've got 2 minuses headbutting each other, so it's a plus, and then 4 divided by 1.5 is 8/3, or 2 2/3. So even though, 4 minus 2 is 2, 2 plus 1 is 3, 3 minus a half is 2.5, it's going to keep oscillating, and eventually it's going to oscillate to 2 2/3. Okay, so some of the applications of limiting sums are to do with recurring decimals. Okay, so if I've got 0.252525, okay, that's a recurring decimal, and if we break it up, there's the first 0.25, there's the second 0.25, but we've passed 2 places to get there. There's the next 2.25, but I've passed 4 places to get there. So what we have is a GP. That's the value of r. Okay, that's straightforward. And then to find the value of that's the value of a. Sorry. To find the value of r, just divide those 2 terms, and you get 0.01. So a over 1 minus r is 0.25 over 99. Now I'm not too sure if your calculator will do that with the fraction button, but the way we did it without buttons is we just jumped that two places, so we've got 25 over 99. And if you check 25 over 99 on your calculator, you will get 252525. Okay, so let's have a look at another example. So in this next example, I've got 0.233333. So the 0.2 is not repeating, it's just the 3's. So we just separate the 0.2 away, and then we've got 0.03. We had to jump a spot to get to the first 3, and then after that we're just moving one place each time. And it's this part is the limiting sum. This part is just a fixed number. So we have a look at this part here. So we've got A is 0.03, R is just 0.1. We're just going back one place each time. So the limiting sum of that second part is 3 over 90. We move that two places, so we move that two places and then fill it with a hole. And then on your calculator, obviously, or maybe not on the calculator, 0.2 is just 2 over 10. So on your calculator, 2 over 10 plus 3 over 90 equals 7 over 30. And if you check that on your calculator, you will get that number back again. Okay? And I think that's our last thing. So on exercise 5H, there'll be practices, maybe not with recurring decimals, but applications of limiting sums. Okay, thanks.